Alright, so we have a polynomial. We switch the variable, right? I hate that. So now we have it's x to the 4 minus 4x cubed plus 5 plus lambda x squared minus 4 lambda x plus lambda. Yeah? And we want to show lambda equals 1. So if it's real and positive.
We've already dealt with one case.
So we got by AMGM that the sum of the roots that is greater than or equal to the product of the roots to the 4th power, yeah? But this is just equal to 1. And this is equal to the 4th root of lambda, yeah? So lambda is less than or equal to 1.
Yeah.
So we just want to show lambda is greater than or equal to 1. But I feel like this idea is very kind of revealing. Don't you think? Like once that works, it feels like the sky's the limit for this kind of thing. So I guess it was a pretty nice idea for a question.
Just the one to look at next is the 5 plus lambda term.
Yeah.
Because that's like the one that has size. Because right now, we got by the other one that it's small. But the 5 plus lambda is the one that kind of has some sort of like big size. Maybe.
Like degree 2.
Not like, oh.
Or degree 3. Yeah. It's kind of funny. It's like we learn polynomials and we do a polynomial problem. Either it's related to the stuff that we learned and it's a good application, or it's not and we fill a gap that we missed.
Yeah.
Alright, so what are you saying? So we do the roots 2 at a time. Alpha gamma plus alpha delta. That is equal to 5 plus lambda. Yeah?
Yeah.
So this is Vietas. And then we have alpha beta gamma plus alpha beta delta plus alpha gamma delta plus beta gamma delta is equal to 4 lambda, right? Yes? Huh.
Can't we just take...
Wait, that's equal to like the sum on lambda, right?
I can...
This equals like lambda on delta.
I can get something, Michael.
This is lambda on gamma.
Michael, I've got something.
Is it related to what I'm doing?
No. Oh, it's using the AMGM idea again.
On different coefficients?
On the 5 plus lambda thing. Because we AMGM that entire thing, right? And we get 5 plus lambda on 6 is greater than or equal to what's it called? The square root of lambda.
5 plus lambda on 6?
Yeah.
Oh. So it's 6th power of like, but it's cubed, is that what you're saying?
Oh yeah.
5 plus lambda on 6 is greater than or equal to the square root of lambda?
I think it's cubed root.
It's the 6th root, right?
No, but every term's counted twice, right?
3 times.
3 times. Oh yeah. Then it's the square root. Because we get a cubed, alpha cubed, beta cubed, square root lambda.
Okay.
Because then that gives us some boundy thing on that. I guess this one might be more interesting to like go and solve it. Squaring.
So if lambda was 1, we get 1 is greater than or equal to 1. Okay, that's good. If lambda equals 0, we get a 516 is greater than or equal to 0. Lambda is equal to like half. Oh, so lambda is allowed to be less than 1 for this.
Yeah, but it's not. It's going to be pretty close to 1. Like
No, like half works.
half works, does it?
I think so. Like 5.516 is greater than 1 on root 2. Is it?
Let me double check.
Yeah, 5.516 is close to 1, right?
Yeah.
And 1 on root 2 is not that close to 1.
I'm solving it.
I think this one's promising.
Hmm.
Because this is literally the opposite of what we had.
Oh. 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 Wait. Do we actually? Wait. Do we have that?
I think so.
Oh yes, that should do it.
Because it's literally 1 over lambda, right?
Yeah. Then we have 1 over lambda.
It's less than or equal to 1.
Yeah. Then we're done. Very nice.
But you know why we got that, right?
Yeah, it's the opposite of that thing because we have the all multiplied together is equal to 1. Or lambda.
Oh wait, there's one thing that's slightly wrong. Oh no, yeah, lambda's the positive product.
Yeah,
Like there's no minus sign.
exactly.
And what's the point of the 5 plus lambda? Is that just not used?
Must be. This question, I feel like there are probably better polynomials. Like it's just that does it.
Well, I'm confused now. Wait, so what if you change the middle coefficient?
Middle.
Like if you change this thing, right,
Yeah.
to any function of lambda, would that work still?
Wait. How exactly do you get the 4 with 1 lambda thing? Again.
Like, I look at this thing here, right?
Yeah.
That's equal to the sum of roots 3 at a time, right?
Yeah.
So that gives me this thing here.
Yeah.
Yeah?
Oh, and then divide by lambda, which is the product of the roots.
The lambda is the product.
Oh yeah, then that shouldn't affect it.
Huh?
Then that shouldn't affect it in the middle term.
Isn't that weird though?
Yeah.
So you're saying I could make the middle term like 1,000,000,000.
This question is, I think, kind of artificial. Like, maybe there's a solution that uses it, but this does it.
I guess that thing, it has to be consistent. Or maybe it's for the converse.
Which one?
Like the converse.
Oh, it is for the converse, yeah. Yeah.
Because if it's some other function, converse might not be true?
Yeah.
Are you sure?
Changing the middle, it shouldn't always have a root of 1. Like,
Yeah, so like sometimes the middle will produce a contradiction, right?
yeah.
Oh, like if it was another thing, you might not be able to show the converse very easily. Is that, do you reckon, the reason?
Yeah. Yeah, because having the middle weird will make it hard to solve.
I mean, you only need to show like the intermediate value thing.
Yeah. Oh yeah, true. But still, it's going to be annoying. It's probably just to make it a nice solution. But yeah.
Right, so I could literally have uh, wait, you could have contradictory stuff there, right? Like you could put like because what's that? That's the sum of the roots 2 at a time, right?
Mm.
Like you could put that as negative lambda or something, couldn't you?
Yeah.
Oh wait, hold on. Wait, at some point we concluded lambda had to be positive, right?
Yeah.
How do we do that again?
Lambda is the product of the roots.
And they're positive.
Yeah.
So that's only the constant term.
Yeah.
Oh, so we use that. So that's the 5 plus lambda is the only thing that's not used. Yeah?
Yeah.
And if lambda's positive, oh, okay. Yeah, so I guess 5 plus lambda is the only obvious, like it's an obvious non-contradiction. Yeah?
Yeah.
Like you could put like a minus lambda here as well.
Yeah.
Which is not be true, right?
Mm.
But you can still prove that it's equal to 1.
Yeah. The problem's pretty artificial. Like, it's trying to force you to use this AMGM on the Vieta.
Yeah.
I knew for a fact there was just going to be something doing with Vieta. It's not really a question about, like, a good polynomial question, I feel, is one that asks you something about the nature of polynomials, you know?
Mm.
There's a bunch of supposedly really, really tough RMM problems about polynomials. Or RMM shortlist. There's some ones from 2020.
Okay.
The 2020 RMM shortlist is too tough, like very, very tough problems about polynomials.